Good evening, dear all second year mechanical engineering students. I am Dr.Ram, Associate Professor, Mechanical Engineering Department, JRIET. For both the section, I am dealing Production Technology Laboratory. And today the topic that I am going to discuss with you is on molding sand. So initially, in our chapter number 1, we are going to learn about casting process. So for doing the casting process, there are 3 things required. The one will be on pattern, the other one will be on molding sand, the third will be on casting process. So everyone knows about what is meant by pattern. So pattern is nothing but an example model of component that you are going to prepare. That is called as pattern. A pattern can be prepared with the help of wood material, or with the help of a metal material, or with the help of a plastic material, or with the help of a quick setting compounds like a gypsum cement or a plaster of Paris. So that is called as pattern. The second one is called as molding. So for preparing the molding, the main constituent that required is sand. First of all, we must know what is meant by molding. So mold is nothing but the mirror image that we will get. That is nothing but the impression that we will get on the molding sand is called as mold. So how will you get this mold? So the first step will be preparation of pattern. So with the help of pattern, we can prepare mold. So how you will prepare the mold with the help of pattern? So you take the pattern which is prepared with the help of either with a plastic or with the wood or with the metal material or with any quick setting compounds will be taken. And parallelly we will be taking sand. Sand will be mixed with water, binders and additives, and it will be kept in the semi-solidified condition. Now we will take the pattern and we will make the impression on the sand with the help of the pattern. So we can make a number of impression on the molding sand. We call it as molding sand normally. We can make number of impression on the molding sand in order to get a hollow cavity on the sand. That hollow cavity we call it as a molding. We call it as mold. And once we achieve this mold, what we will do with this mold? The third step will be on casting. Casting is a process of melting the raw material and pouring it into the mold cavity. That is called as casting. So once you melt the raw material, and the raw material is nothing but our metal scraps. So once you melt the metal scraps, the hot molten liquid will be poured into this mold cavity, and later on it will be made into solidified. And after removing all the sand particle, you will get the component. It is something like in the refrigerator we have ice tray box. Ice tray box will be having number of cubes. So ice tray box is said to be as a mold cavity. So inside the ice tray box we are going to pour the water and keep it in the freezer in order to solidify it. And after solidifying we are going to take it and we are going to take all the ice cubes outside. Similar manner, in the same way, with the help of pattern, we are going to make the mirror impression on the sand, and after that pattern will be taken outside. We will get the mold cavity. After obtaining the mold cavity, raw material will be melted on the other side from the furnace, and the hot molten metal will be taken from the furnace and poured into this mold cavity. That is called as casting process. So in a simple manner, we can define the casting process is the process of melting and pouring the hot molten metal into the mold cavity, which is prepared by a pattern, is called as casting process. So in this casting, these 3 terms will come. Pattern will come, mold will come, as well as casting also will come. So today we are going to discuss about the topic on molding sand. In order to prepare mold, we need sand. So why we are going for a sand material? Why not other material? Maybe like metal material or some other material, something like furnaces. Why we are going only with the sand? Sand is the only one material which can able to withstand high temperatures. So in the ancient time, before this gas stoves and induction cookwares were all invented, people used to cook with puff sand. So they used to make a sand. They may used to arrange a sand like in the shape of a furnace, and in between the sand they used to keep all the bricks, and they will fire it. once they fire it, that sand cavity also will become very hard in nature. So they, on daily basis they will be cooking on the same sand material. Once it is formed, it will have enough strength to occupy its own shape. So daily they used to cook with the help of that sand only. So sand is only one material which can withstand high temperature of cooking. If in the place of the sand, if you put a metal material or with other material, when you pour the hot molten metal into the mold cavity, it will melt. For example, cast iron. The melting point of cast iron is roughly around 1800 degrees centigrade. The melting point of some ferrous metals is roughly around 1380 or 1400 degrees centigrade. Non-ferrous metals like copper melting point is roughly around 1400 to 1800 degrees centigrade. So it will melt. So in order to avoid the melting of the furnace, we are using sand in the place of the furnace. So with the help of sand we can able to. So today we are going to study the topic on sand. So why we are preferring sand, what are the characteristics itself, and what are the properties of a sand that we must know in the point of casting point of view. So first one is characteristics of molding sand. So molding sands are refractory in nature and it can withstand temperature of metal being poured without fusing. Actually sand is a ceramic material. Ceramic material can withstand high temperatures. And so in our casting process, the hot molten metal will be roughly around 1500 degrees centigrade to 2000 degrees centigrade. So sand is having that capability to withstand the temperature. So that's why sand is preferred in the casting process. The second one is molding sand do not chemically react with molten metal. Say some example, ferrous metal, non-ferrous metal. They are having number of composition like carbon, iron, silica content, magnesium content, manganese content. Various contents are there with the metal materials. So this sand will not react with any metal elements. It doesn't react. Some other, for example, if we put a furnace in the we'll take a furnace. In the furnace there is a mold cavity. So you are pouring the hot molten metal into the furnace. Furnace is a ferrous metal, maybe made up of ferrous or it may be made up of non-ferrous. So the metal that you are pouring, it will be having some chemical element that will be reacting with the furnace and it will combine into a what we call the third type of element called intermediate phases and alloys. It will be forming like that. So molding sand doesn't react with any molten metal. The third point is sand have high degree of permeability. So what is permeability is also called as porosity. That is the ability of the sand. It allows the sand when a hot molten metal is poured into the mold cavity. Sand allows the hot gases to escape from the mold cavity. If these hot gases are not escaping out of the mold cavity, what will happen? Bubbles will be formed in the component. If bubbles are formed, we call it as crack, we call it as porosity, we call it as air bubbles. That is one kind of defect that will normally occur in castings. So the ability of the sand, which makes that hot gases to escape the moment when the hot molten metal is poured into the mold cavity, it is called as permeability. Then the other characteristics will be on strength, hardness. Hardness can be determined with help of compressive strength or tensile strength, like that. And hardness can also be measured by varying the changing in the structure of the sand. And these are all the various properties of the molding sand that we have. First one is refractiveness. Already I discussed in the last slide. Refractiveness is nothing but the ability of the sand which can able to withstand high temperature of the hot molten metal. That is called as refractiveness. Second one is good strength. The sand must be having a very good strength to accommodate by itself. For example, bring compressive strength, we call it as ability to have compression, ability to observe the compression occupied during at the time of pouring the molten metal. Next one is shear strength. Once the sand is formed with the bias and additives and other thing, it must have some ability to withstand the shear force by itself. on sudden some small external forces acting on the sand, it should not collapse by itself. So there must be some compressive strength and there must be some shear strength. So these are the ranges for the shear strength and the compressive strength. You can see it on the slide. The shear strength is for about 10 to 40 kilopascal, compressive strength for 130 to 160 kilopascal. Third one is dry strength. So when the hot molten metal is poured into the mold cavity immediately, the sand around the mold cavity is quickly converted into dry sand. It is nothing but it should retain the mold cavity. Without collapsing the mold cavity, it should retain it. That is called dry sand. Next one is hot strength. Strength of the sand that is required to hold the shape of mold cavity after all the moisture is eliminated. Once this after pouring the hot molten metal into the mold cavity, this hot gas will go inside. All the moisture will go inside. So the shape of the mold will be remained. For making it to remain, the property we call as hot strength. Permeability already I discussed. It is nothing but it allows the hot gases to escape outside. Next one is grain fineness number. The average grain size distribution of given mold, that is called as grain fine size number. Normally, greater the grain fineness number and lower the grain size. That will be the condition that we prefer in the casting process. Next one is flowability. So sand must be, once the sand is mixed with water, binders and additives, it must be little bit flow in nature. Then only it can able to flow around the pattern. The moment when we keep the pattern in the center, the sand can able to flow and covers all the pattern in that area. Next one is adhesiveness. The property of sand mixture to stick on to the another body. For example, we have at the time of making molding, the sand has to get stick with the molding box. Molding box is made up of ferrous metal. So it should have the ability to stick with the another body also. Cohesiveness is nothing but sand must have the property of sticking with the another sand particle. Then only we can able to fuse the sand one to one each other. We can able to join one to one sand each other with the binders, additives and other resins. That is called as cohesiveness. So these are all the various properties of molding sand that we have. Thank you.